limit of sine and cosine, and the indeterminate forms. In this video, we shall show the first indeterminate forms for sine and cosine, and we shall show how to find their limits. We shall present this as a theorem, but we will not give a formal proof about why these sine and cosine functions came to have these limits. So this is not a formal proof. Theorem 1.11, limit of indeterminate forms of sine and cosine functions. The limit of sine of x divided by x as x approaches 0 is equal to 1. The limit of 1 minus cosine of x divided by x as x approaches 0 is equal to 0. Let us apply what we know about the properties of limits. So this is an indeterminate form. It doesn't mean that the limit is equal to 0. It doesn't mean that the limit is equal to infinity. It is indeterminate. So we have to find ways to really find out what is the true limit of this function, sine of x divided by x as x approaches 0. We can return to our theorem on the existence theorem of limit using one-sided limits. So if the one-sided limits are equal, they are equal to the same real number L, then we are saying that the limit of the function exists and it is equal to L. And so what we shall do here is we shall investigate the one-sided limits of this function, sine of x divided by x. What is the limit of that as x approaches 0 from the left and as x approaches 0 from the right? We will find the limit of sine of x divided by x as x approaches 0 from the right. What is that equal to? And we will also find what is the limit of sine of x divided by x as x approaches 0 from the left, and what is that equal to? Well, we can do that with the help of a table. So here, in the first row, we have values of x to the right of 0. So we can begin with 0.1, 0.01, 0.001, so on and so forth, until we get to something that is a small real number that is closer to 0. And then the second row is sine of x, and the third row is the value of our function, sine of x divided by x. Look at what's happening here. As x approaches 0 from the right, the value of our function approaches this. And what is this equal to? That is your sine of x divided by x is approaching the value of 1. Okay? So we can say here that how about when x approaches 0 from the left? So from the left of 0, we have negative real numbers. So we can begin with negative 0.1. We can go to negative 0.01. Okay? As we get closer to 0 from the left. This is the value of sine of x. This is the value of sine of x divided by x. And look at what's happening here. As x approaches 0 from the left, the value of our function approaches 1. Conclusion, since the one-sided limits are equal, and it is equal to a real number 1, the limit of our function exists and it is equal to 1. Now we can also look at the one-sided limits of our function by looking at the graph. So this is the graph of the function defined by y is equal to sine of x over x. As x approaches 0 from the right, okay, 0 from the right, the value of our function approaches 1. As x approaches 0 from the left, look at that, the value of our function approaches the same point, and the value of our function, or the value of our function at that point, is also 1. Conclusion, the limit exists and it is equal to 1 because the one-sided limits are equal and it is equal to a real number 1. So that is how you reason out. That is how you reason out when you are using the one-sided limits to establish the existence of limits. Find the limit using algebraic methods. So this is the second part of our theorem, and we shall solve this using what we know, the techniques of resolving indeterminate forms. But before you can proceed with finding the limit, you must first show that this is indeed an indeterminate form. So this is an indeterminate form. So what I'm going to do is I will use the method of multiplying the function by its conjugate. And let us see where that will bring us. So this factor here is just equal to 1. So it's not changing our original function because any function multiplied to 1 is still the function itself. Now look at this. 1 minus cosine of x times 1 plus cosine of x. It has the form a minus b times a plus b. And you know what that is equal to? It is equal to a squared minus b squared. So this one is going to be equal to 1 squared minus the square of cosine of x divided by x times 1 plus cosine of x. Now, pay attention to this. 1 minus square of cosine of x. So we have this identity. We call that the Pythagorean identity. It says that sine, the square of sine of x plus the square of cosine of x is equal to 1. And what that means is the square of sine of x is equal to 1 minus the square of cosine of x. So what that means is we can replace this numerator with sine, or the square of sine of x divided by x times 1 plus cosine of x. So the square of sine of x, that is just equal to sine of x times sine of x. And then, look at this, x times 1 plus cosine of x. Okay? Looking for the limit of our original function, 1 minus cosine of x divided by x as x approaches 0. That is just the same as finding the limit of this function as x approaches 0. Okay, so what is the limit of sine of x divided by x as x approaches 0. Well, we just showed it as the first of our theorem in this slide. This is equal to 1 times what is the limit of this function as x approaches 0. So we can just apply our limit theorems on circular functions. So this is equal to sine of 0 divided by 1 plus cosine of 0. So what is this equal to? This is 1 times this. Sine of 0 is 0. And then 1 plus cosine of 0 is 1. So this is 0 over 2 or simply equal to 0. So this whole thing here is equal to 0. The limit of 1 minus cosine of x divided by x as x approaches 0 is 0.